Hello again to another Aga Color React, and today we will be watching. Let me explain why it would be preferable to colonize Titan instead of Mars from insane curiosity. And let's just start.
Until now, most researchers have considered the Moon or Mars as the ideal targets for the first step in colonizing our solar system.
Well, because they're close.
These destinations have the dual advantage of being close enough to Earth and presenting surface environments that are not entirely hostile to current technological capabilities. Among other possible destinations, Mercury is too close to the Sun, with extreme temperatures and other physical conditions that seem difficult to overcome. Venus is much closer, but its atmosphere is poisonous, extremely heavy, and scorching due to uncontrolled greenhouse effects. However, even though the Moon and Mars may seem like relatively reasonable destinations, they also have fundamental problems. Neither of these planets are protected by a magnetic field or a significant atmosphere, which would force any future colonizers to live in underground shelters to protect themselves from deadly cosmic radiation. And just so you know, is there anyone among you who would want to go to a brand new world only to spend their life in an underground tunnel? In fact, this is a problem for which no solution has been found. So much so that more than a few expert planetologists have recently begun to suggest that the ideal goal to attempt to build the first human colony is neither the Moon nor the Red Planet, but Titan, Saturn's large moon. This hypothesis sounds
There's water there, isn't it?
unexpected,
That's why.
given the temperature on Titan's surface
And there's
is
atmosphere as well.
around minus 180 degrees Celsius, with rains of methane and ethane flowing into hydrocarbon seas. However, scientists are confident that this is the only place where people can build a self-sufficient colony in the long term. Do they have a point? To find out, let's try to list all the potential advantages of such an apparent bizarre choice. Are you ready to join us? Let's get started.
I don't think it's such a bizarre choice. That was quick for an ad. Like I said, I don't think this is such a bizarre choice for them Titan to be the actual being colonized first. And well, that's what it is. I think it's because there's actually liquids, the rains and stuff. Maybe not rain as in from water, but still there's something else there. So basically it's possible to get that stuff, a lot of things that we're gonna need anyway. So that's this. This one is the second one is much longer, so I'll see you soon. Okay, I'm back, and I'm just gonna go straight into it and see what's going on.
Is one of the most enigmatic moons in our solar system, is the second largest after Ganymede. With its thick atmosphere and unique geological features, this moon of Saturn is a world that has increasingly captured the attention of astronomers and astrobiologists over the years. Unlike any other moon, Titan possesses a climate model remarkably similar to that of Earth, with distinct seasons and weather conditions that can offer clear, cloudy, very windy or rainy days on that remote world. Its surface features dunes, rivers, deltas, lakes, and seas. Keeping in mind that we're still talking about an alien environment where average temperatures are around minus 180 degrees Celsius, let's explore all its positive aspects for potential future colonization. The atmosphere of Titan shields the surface from cosmic radiation. Without an atmosphere dense enough to protect their surface from solar radiation, especially galactic cosmic radiation, any colony would ideally have to be located underground. However, Titan has by far the densest atmosphere of any rocky body in the solar system, apart from Venus, which reduces incoming radiation to a negligible amount. A planet's atmosphere is particularly effective at keeping away the most deadly radiations, those coming from within our galaxy. The potential carcinogenicity of these radiations has been known for some time. although it remains poorly quantified. Radiations can ionize the atoms they pass through, passing almost unhindered through a typical spacecraft or an astronaut's body, destroying brain tissue and leading to the loss of cognitive abilities. On Earth, in addition to the magnetic field, we are protected by the water in the atmosphere. But on Mars and the Moon, virtually devoid of a gaseous envelope, it would take 2 meters of water to block half of the incoming radiation, or 4 meters of soil. To protect against radiation, Titan has an atmosphere more than 50% thicker than Earth's, not to mention that Saturn's gigantic magnetosphere also provides shelter. Before moving on, don't forget to subscribe to our channel if you haven't already. Make sure to hit the notification bell so you don't miss out on our daily videos. You wouldn't need a pressurized suit on Titan's surface. Most rocky planets and all other moons in the solar system have little more than traces of an atmosphere. Even the atmosphere on Mars is a little denser than a typical laboratory vacuum here on Earth. However, Titan's abundant atmosphere also means that the air pressure is much more comfortable for human visitors. It's only 50% higher than that of Earth, which is perfectly manageable, so colonists could move on the surface without the need to wear uncomfortable pressurized suits. The dense atmosphere allows for much greater thermal exchange with the environment, so heated and super-insulated suits would be needed, along with, of course, an oxygen supply respirator, nothing that is not already within our reach. Titan hosts the richest nitrogen atmosphere in the solar system. Titan hosts the richest known nitrogen atmosphere, so colonists would only need to add oxygen, using the existing nitrogen as a buffer to create breathable air. In fact, Titan's atmosphere is already composed of over 98% nitrogen, compared to our 78%, making it more similar to Earth's atmosphere than any other in the solar system.
So terraforming, it's more
no oxygen, but there
probable.
are deposits of water ice located just below the moon's surface. From there, one could easily obtain oxygen for breathing and for burning hydrocarbons. Colonists would need to live inside sealed structures with controlled atmospheres. Furthermore, the use of advanced spacesuits would be essential for outdoor missions. Oxygen production through water electrolysis or genetically modified plants could contribute to creating a breathable environment. Titan has rivers, lakes, and seas. Titan is the only object in the solar system, apart from Earth, known to host significant amounts of surface liquids. In fact, it showcases seas, rivers, lakes, and even rain and glaciers, just like our world. However, instead of water, Titan has methane and ethane, which remain liquid at temperatures of minus 179.5 degrees Celsius. With an abundance of solid and liquid hydrocarbons on the surface, Titan has all the fuel a colony could need. In fact, it contains hundreds of times more natural gas than all known reserves on Earth. Fortunately, in Titan's oxygen-free atmosphere, these liquids are not even flammable, making their conversion into fuel much easier. However, even though it's not visible, there is an abundance of water. At temperatures twice as cold as the coldest ever recorded on Earth, water on Titan's surface will be permanently frozen and as hard as granite. However, even though there isn't an internal salty ocean, there's still a lot of frozen water on the moon's surface and locked in the rocks below. Scientists believe that Titan's outer shell is largely composed of water ice, which should not be too difficult to extract. The seas of Titan could provide polymers for construction. With its practically infinite supply of liquid and solid hydrocarbons, Titan also has everything colonists would need to build up permanent shelter. Instead of relying on wood, bricks, and metal as we do mostly here on Earth, this orange world would be the ideal place to use space-age polymers to construct sustainable surface structures. Thanks to the thick atmosphere and Saturn's magnetic field keeping the surface free from harmful radiation, colonists would be able to build surface habitats instead of having to carve vast underground shelters to escape surface hazards.
It's easy to avoid getting clamped if you park correctly. Street signs will tell you if you can park and at what times. The signs may
So, problems with everything here now. I don't know what's going on. Okay, let's see. And volume. Okie dokie. And I just gonna be gone for a moment because now I have to check what's going on my computer. So I see you soon. Bye. So I'm back after a bit of a technical difficulty, and I think I'm in the right spot in the computer as well.
The challenge is energy. Given the great distance from the sun and Titan's dense atmosphere, the use of solar panels becomes inefficient. Titan's atmosphere is about 10 times thicker than Earth's, implying that the brightness of the sky on Titan at noon through its thick layer of clouds might be very similar to Earth's sky 5 minutes after sunset. One solution could be to use advanced nuclear reactors or harness local resources like the lakes of methane and ethane to generate power. Additionally, the use of alternative energies like wind or hydrogen could be considered. There is so much nitrogen in Titan's atmosphere that we could use it as fertilizer just like we do here on Earth. Although Titan is inhospitable in itself, it seems to contain everything needed to build a completely self-sufficient colony, which would be vital given its great distance from Earth, 1.2 billion kilometers. Food production would be a critical challenge. Colonists would need to develop greenhouse cultivation systems that can operate in Titan's cold temperatures and use methane as a source of carbon for plants. Furthermore, cultivating resilient microorganisms that can convert local resources into food would be essential to ensure a sustainable food supply. Fortunately, Titan provides all the fertilizer that colonists could need to grow food. Its nitrogen-rich atmosphere, combined with an abundance of methane and ammonia, could be used to grow crops and establish a self-sustaining ecosystem. Resources nearby. The Saturnian system hosts 62 moons and multiple rings composed of
more like 100 and
billions
something
of
now.
icy particles. Although Titan represents almost all the mass orbiting Saturn and is by far the largest moon of the planet, the abundance of other bodies in the Saturnian system also presents significant economic and exploratory potential. For example, nearby Enceladus hosts an underground ocean of water, kept liquid by tidal friction caused by Saturn's immense gravitational attraction. This makes it one of the places in the solar system with the highest likelihood of finding extraterrestrial life. A permanent base on Titan would be ideal for use as an outpost, a launch pad to numerous other destinations in the outer solar system. We could even fly there. By far the simplest and most economical way to explore Titan would be to simply put on a pair of wings and fly. Due to its small size and low density, Titan has a surface gravity of only about 14% of that of Earth, which is slightly less than that of our moon. The extremely high ratio of atmospheric density to surface.
Another ad. Hopefully everything will work this time. And okay. So yeah, I didn't realize. Well, did I probably heard about the fact that the gravity is much lower than moons? Still, I'll be like, woo, woo. Excuse me. And do I have anything else to add? Yeah, Titan, with the possibility of actually growing food, is definitely something that we should and we probably will think about in the future. But they're gonna be in the future. But first thing what we have to do is probably base on the moon to just gonna get some kind of footing and some experience of actually building it and supporting ourselves out in outer space on other places, not just on Earth. So okay, let's just go back. And there you go.
Density to surface gravity also significantly reduces the wingspan required for an aircraft to maintain lift, to the point where a human could sustain flight wearing a sort of winged suit that could easily be produced with today's technology. Fear of falling? No problem. The free fall acceleration is 7 times lower than that on Earth, and the maximum falling speed, accounting for air resistance, is 10 times lower. In the case of a fall from any height, it would not be possible to impact at a speed greater than 18 kilometers per hour. Okay, all interesting and exciting, but this certainly doesn't mean that Elon Musk or NASA will rush to change their destinations for upcoming missions. Unfortunately, Titan is a distant world, and its favorable characteristics will not be enough to convince us Earthlings to spend at least $400 billion to get there, when in 20 years we could plant the flag on a peak of the red planet with just $100 billion. Certainly when it comes to Titan, we're talking about colonization, not just a brief visit like what's planned for Mars. This means that a spacecraft specifically designed to carry a substantial number of humans and the necessary resources for survival on Titan would need to be constructed. The spacecraft should be self-sufficient for a long-duration journey and capable of sustaining human life for months or even years. The crew would need to be carefully selected and trained to face the unique challenges of life on Titan. Astronauts should be multidisciplinary with expertise in sciences, engineering, medicine, and other disciplines necessary for survival. Before sending humans, it would be wise to dispatch advanced robotic missions to prepare the groundwork. These robots should undertake tasks such as building shelters, gathering resources, and preparing the environment for the arrival of the human crew. Once on Titan, astronauts would need to land safely and begin establishing a colony. This phase would involve constructing habitat structures, producing food, and implementing life support systems that can function in Titan's unique conditions. All of this will cost a significant amount of money, and it can only happen when we have found a more efficient propulsion technology than chemical rockets. It won't occur in 20 years or even 100. Likely we'll truly begin to consider it in a couple of centuries, after we've drawn the first conclusions from the colonization of Mars. Even that is not guaranteed to succeed.
Okay, that was really interesting. But like I said, it's gonna probably take a couple hundred years before we actually get to think about colonizing Titan. So, do I have anything else to add? Oh, it's a really good video too. So, thank you very much for watching. See you tomorrow, and sorry for the interruptions. Bye!